Okay, so we learned a lot about schemas and relations. Let's practice that a bit. And here's a simple example project which I want you to think about how you would structure the data for it. And then of course we'll also do it together. So we have our user in our application, and that can be a server-side rendered website, a single page application, a mobile app, anything like that. We got our app server. And in that app server, or to that app server, we send a couple of different requests. Because let's say we're building a blog, as the title says. So users are able to create posts, edit posts, delete posts, fetch all posts so that we can display a list of posts on a page, fetch a single post so we can read that post, and also comment posts so we can write comments. And we can also fetch these comments, of course, to display them. Now, we got our application server with our code being written in Node.js and .NET, PHP. We won't write the code here. This is not a web development course. We won't write any code here. We'll just structure the data for that and see how such a dummy request, how such a write or such an edit could look like. Our code in a real app would, of course, use the Mongo driver. We will use the shell here. And in the end, it'll send the data, the request, to the server. So our goal here now in this exercise is to simply define a schema, identify the core entities we have in this world, and how the schemas for these entities could look like, how they are related, and how we would model these relations. And then we'll just play around with some queries so that we can see how our application, how the MongoDB driver would interact with our database. So let's have a look. I'm drawing on my iPad here, and as I mentioned, definitely go ahead, do this on your own. Definitely lay out the core data entities you have and how they might look like in your application and how they could be related. There is no single correct solution here, but I'll go, well, with my approach now. So which kinds of data do we have? Well, in our single block, we have at least a user. We have our posts, so we have a single post. And we'll also have a comment, because users can comment posts. So these three data entities here should exist. Now, which kind of data does a user consist of, does a post consist of, and does a comment consist of? They will all have that underscore ID, of course, because that is a hard requirement by MongoDB. Then a user might have a name, might have an age, and might have an email, let's say. A post might have a title, might have a text, and whatever else you want, maybe some tags. And obviously, you might come up with totally different fields here. Now, that is how that could look like. A comment will simply have some text, let's say. How are these entities now related? Well, a user can create a post and, of course, edit and delete it then. A user can also comment a post. So a post can have multiple comments where each comment also knows which user created the comment. These are the general relations we have in there. How could we now model that? Well, we got the whole variety of things. We could embed everything. We could go with one collection only. Let's say the post collection is our only collection we want to go with. And in posts, we then have our user, and that is an embedded document which holds the user data as defined here. And in post, we also have our comments, which is basically an array of nested documents. Sorry for my super ugly drawings, but here we would have that comment data in an array. So this would be the only collection we then have. Posts with embedded users in a single post, or the embedded user, and embedded comments. Now, is that a good approach? Well, parts of it are good. I'm fine with embedding my comments here, because the comments are a one-to-many relationship. A post can have many comments, but a comment always belongs to one post. A post also typically doesn't have millions of comments, so we probably don't hit any MongoDB limit, and we often want to fetch a post along with its comments. So nesting the comments here might be fine. You can always go for a different solution, but I'm fine with nesting comments. What about nesting the user? I don't think that is a good idea. Nesting the user doesn't sound too good to me, because if we nest a user here, then we have a problem, because one user can create many posts. So if the user data then changes, let's say if the email changes, we have to edit that user in all the posts. So we got a lot of duplicate data. And whilst that might not change on a daily basis, it certainly is not like a user never changes any data. So it's not such a low frequency that I would be fine with doing all these duplicate changes when they occur. So I'm a fan of actually creating two collections here. The users collection and the posts collection. We'll not have a comment collection. We'll have comment data in this structure in our array here, but we'll not have a separate collection for comments. Instead, we'll have posts and users, and we'll use these collections with some embedded documents for comments and also for tags, by the way. Tags also in the end is just an array of strings, so we could also say that this is a relation to different tags. So we have two major collections, posts and users. This is my solution, and I hope my explanations here are clear why I would not use a comments collection, even though you can of course do that, and why I would not use nested users. Now, let's go back to the shell and play around a bit with that and see how we could implement that there.